Some examples of one-sided limits. The limit as x approaches 8, so the plus means from the right of x plus 8. In many cases, where there is a limit for that function at this value, then obviously the limit from the right is going to be whatever that limit is. And so you can just do direct substitution. Right, in this case, the limit is equal to the limit x approaches 8 from the left of 1 over x plus 8. Those are both the same. The limit as x approaches 2 from the left of 2 over x plus 2. And again, this function has a limit at that value, as you can see by plugging it in. Equals 1 over 2, so in this case, if we're approaching 2 from the right, get the same value. So we have the limit as x approaches 5 from the right of x minus 5 over x squared minus 25. If we just plug in the 5, we end up with an indeterminate form because we get 5 minus 5. 5 squared minus 25 is 0 over 0. And so we need to find an equivalent function. So we'll take this guy, and we'll say that this is equal to x minus 5 over x plus 5 x minus 5, which you cancel out, 1 over x plus 5. That won't give us any issues, so we say this limit is equal to the limit as x approaches 5 from the right of 1 over x plus 5. Again, this function at 5 has a limit, and if it has a limit, then the limit as it approaches 5 from the right is going to be that value. So we end up with 1 over 5 plus 5, which is 1 over 10. Right, another one like that, limit as x approaches 4 from the right of 4 minus x over x squared minus 16. If we just plug in 4, we end up with an indeterminate form. So here we'll have to find an equivalent form. Do this. Negative x minus 4 over x plus 4 x minus 4 is equal to, just cancel it out, is equal to negative 1 over x plus 4. That will help us out over here, so duplicate that. Is equal to the limit as x approaches 4 from the right. Just put the negative up there to make this a little easier to read. And we'll just plug in the 4, so we'll get negative 1 over 8. Limit x approaches negative 3 from the left, x over the square root, x squared minus 9. plugged in a 3 here, -3, we would end up with -3/0, which is undefined, which means that in this case there's no limit as it approaches value -3. And we can see that as we got closer and closer to -3 from the left, this would become closer and closer to 0. This is a negative value, so it would be decreasing without bound from the left. It doesn't approach a specific value, so we say there is no limit. Limit as x approaches 4 from the left, square root of x minus 2 over x minus 4. One of those cases where we'll need to find an equivalent function. What we'll do here is we'll multiply by the conjugate. So we'll get x minus 4 over x minus 4 times root x plus 2, which is equal to, these cancel out, is equal to 1 over root x plus 2. And so we got an equivalent form will not evaluate to 0. To the limit as x approaches 4 from the left, 1 over root x plus 2. And we can just do direct substitution. 1 over root 4 plus 2, which is 1 over 4. This one is kind of useful to see because this is where you'll see that the limit as you approach from left and right would be a different value. So here the limit, the absolute value of x as we approach x from the left. Now this would be equal to, the absolute value of x is always just going to be x. If we're approaching x from, if x is approaching 0 from the left, that means x is going to be a negative value. So whatever x is going to be negative, which would give us a negative in front there of x over x. Right, this x value on the bottom will always be a negative value. So whatever this x value is, this will be the opposite of it. And that basically gives us limit as x approaches 0 from the left. The top value is always going to be positive. So then this would be, and we're approaching x, right, so it's actually, if you think of it this way, is a better way to think of it. The top value is always, we're approaching 0, x is approaching 0 from the left, so x is always going to be negative. But if we have the absolute value of x, then that's always going to be positive. So negative x is actually always going to be positive, and x will be negative. And if you do that, that's equal to -1. So that's the limit as you approach from the left. If we did the opposite, and we said the limit as x approaches 0 from the right, square root of x over x. So in this case, x is always, if x is approaching 0 from the right, that means x is positive, so we can just leave it outside of the absolute value. That's positive, and that's going to be 1. So you can see the limit as you approach from left to right is different. In this case, obviously, there is no actual limit. It's only one-sided limits. Similar problem, limit as x approaches 10 from the right, x minus 10, absolute valued, x minus 10. So direct substitution would just give us 0 over 0. If we're approaching x from the right, then that means if we found an equivalent form, basically this is the way to do it here, you've found an equivalent form of this function. When x is approaching 10 from the right, that would be the same thing as this, because x is going to be positive. And this is equivalent to 1. And so the limit of this is equal to the limit x approaches 10 from the right of just x minus 10 over x minus 10, and that is equal to 1. If you are having x approach from the left, for the limit as x approaches 10 from the left of that same value, well then this is equivalent to the limit as x approaches 10 from the left of negative x minus 10, because if x is approaching 10 from the left, that means x is less than 10, which means x minus 10 would be a negative value. So the absolute value, we're multiplying it by a negative. And then that would be x minus 10, and that would equal negative 1. So you can see when we, by absolute value functions, we generally have different one-sided limits, and that means that there is no limit for that function.